Okay, imagine the situation. We launched our successful absolute hit web-based game. People are enjoying it, and for some reason, during the peak of our traffic, some junior colleague of us went ahead and accidentally terminated the instance. Or we can go even beyond that. Maybe entire availability zone went down, and the instance in it together with it as well. And when we refresh, when we try to, no, we still can play because it's kind of static HTML, but once it's resolved, or if I open it once again in a new tab, it will not give me anything. Why? Why? Reasonably, because there is no more server behind this IP address. And that's, by the way, the message that I was referring previously. And this one, you can see the page is still loading, page is still spinning. How could we have solved this issue? So the problem following, and we can never avoid this, right? We have some active service that is serving some customers, and the server goes down, or entire data center or availability zone goes down. How could we mitigate this issue? Boris?
Load balancers?
Load balancers good, but
Not good enough?
no, it's totally good, but you've kind of jumped over one step. For the load balancer, we must have something to load balance, right? Which essentially means we need a second server. And yeah, since we started talking to load balancer, about load balancers, there is no point in like me demonstrating it and keeping it a secret. Yes, what we will do, and let me create one more diagram. We'll have two availability zones. We'll have subnets in it, but let's omit this for now, not to overcomplicate the scenario. Of course, all obviously within a VPC. Yeah, let's have this VPC. Inside there will be subnets, but let's not put them. Let's not repeat our networking part. We'll have one instance, where it is. Instance. And we'll have identical, similar instance over here. They will serve the same identical content. And in front of them, there will be a load balancer. Load balancer. And this load balancer will work as a centralized entry point for our users. So user will hit, instead of IP address of this server, a user will hit a load balancer URL. And load balancer will distribute traffic across multiple instances. And the end user, the customer, will not even notice that it was redirected to a different server, because again, the content is identical because the content is absolutely the same. And this is what we're going to implement. We'll distribute our traffic across several instances using elastic load balancers. Does it make sense? Before we jump into demonstrating this, do you have any questions? Abina, you had a raised hand. Do you have a question?
No, sorry.
Okay. If no one have questions, let's move forward and implement this. I've already deployed everything. I have previously offline pulled everything and created a new branch. So first thing we're gonna do is duplicate our public instance. AWS instance public, so we can use count here. Count equals 2 will be more than enough. Security group ID public, remote state public subnet ID at count dot index. And let's slightly change our user data. So right now, instead of the web game, we'll have something like echo ins hello from instance 1 into r/index.html. No, this is not going to work, sorry, because user data is the same. Let's do like this. Host name. Hopefully this will work. So what it will do, it will run the command called hostname. It will print out the computer name, the host name, the server name of this particular instance, and will say hello from instance 1, or instance 1 or instance 2 or whatnot. Hopefully this will work. I don't know, I haven't tested yet, but if it failed, that's great. We'll have an opportunity to find out and troubleshoot together. Let's run Terraform apply. Yeah, that makes sense. I have deleted the original instance manually. That's right. I was wondering why it's suggesting to create 2 of them since I created first one, but yeah, I forgot that during my demonstration we had a different instance deleted previously. Yeah, let's wait a couple minutes to have it applied. Boris, your question?
The way to sync data between the two servers, or is that out of the scope for this class?
Yes, there is a concept of stateful versus stateless application. Stateless application is something that does not store state, that does not have any important information stored in a hard drive, or any configuration, anything is simply either downloaded from Git or baked as an AMI, as we discussed previously, like recreated together with the instance itself. And if we were to like replicate data, take care about some user information, storage, backups. This will be stateful application. That's most likely this will be in a form of database. And luckily, we don't have to deal with databases in like 90% of the cases if we're using AWS, because there are various flavors of managed database solutions where they handle all this replication thing themselves.
Got it. Thank you.
Okay, let's check our instances. So now we have two of them, right? With two different public IP addresses. Let's check. Yeah, very cool. It works just perfect. This one says hello from 1.80. This one says hello from 0.182. But the question is, yeah, how do we distribute traffic between them, and to which IP should we connect? And here's exactly where we're coming and showing and using the thing called elastic load balancer. And let's create one of them. So first thing first, load balancer will have its own security group. Let's give it a name. Let's give it a description. Let's put it into our VPC. We'll have an ingress rule. Which allows port 80. Protocol is TCP, and CIDR blocks are everything. Publicly available game, open to everyone on the internet. And egress, nothing special, just allow all connections out to everywhere. Good. That's our security group. Kind of prerequisite for our load balancer. Now let's create the load balancer itself. There are different types of load balancers, and one dimension is internal versus external. Internal means available only within the VPC itself. External means available outside to the internet. Also, there is different dimension called like type of load balancer. There is classic load balancer, application load balancer, and network load balancer. We'll use application. The difference between the application and network, these are two most widely used load balancers, is that application works on layer 7 of OCI model, network works on layer 4 of OCI model. And we'll put this load balancer into the security group that we just created previously. Let's never forget to run Terraform FMT. And let's apply. And of course, something is wrong. Argument named VPC does not expected here. Perhaps because it should be VPC underscore ID, I believe. At least 2 subnets in 2 different availability zones must be specified. Okay. Yeah, I forgot one more thing. Also, we need to put it in some subnets. Yeah, and this will be data, Terraform remote state level 1, outputs, public subnet ID. We need 2 subnets, and remember that this object contains a list. Let me show you. This object already contains a list of at least 3 subnets, so it will be good for us. Let's try one again. Come on. Yeah, I should not put it in close. There is I hear there is a raised hand, Sanjeev.
Hey Vladimir, so you sent subnets equal to, and then gave the list of subnets, right? So what does it mean? Like
Which line?
the last change you did, subnets equals to the list of subnets.
Yes.
So what does it mean? Like it's saying that your load balancer can span or cater to multiple subnets.
Yeah, multiple subnets, of course. And if we get back to our diagram, where it is, 1 second. Look here. If we get back to our diagram, we'll see that load balancer is distributing across load balancers, across subnets. And what it means is essentially like, if we were to be precise, it will live somewhere in between over there. Yeah, we
Okay,
need
so
to put we need to put each subnet where load balancer will live.
So wherever EC2 is there, that is a understanding, right? You want to serve the EC2 instance in those subnets. So if I have like total 4 subnets, and
Very good question, and I'll demonstrate this in action as well. And
okay.
however, let me clarify this. It should be not in a subnet where EC2 instance, but it should be in a subnet, in a public subnet of availability zone where EC2 instances are running. So load balancer can live in public subnet and distribute traffic to instances in private subnets. And I will demonstrate it to you later.
Okay, thank you.
And load balancer is still creating. Anyone have any other questions in the meantime? Piyush?
Yes, so similar to that question, so there are 3 subnets, so which one it will pick? Any of the random one, or
No,
it will?
it will use three of them simultaneously at the moment. Load balancer is a global resource that should be at the same time, I would say, in all subnets that you want to serve.
Like internet gateway?
Yes, like internet, similar to internet gateway, I'd say yes.
Oh, okay, thank you.
But for internet gateway, you just attach it to your VPC, right?
Mm-hmm.
And for the load balancer, you have to explicitly attach it to each individual subnet.
Oh,
Obviously, that's why there is a list. And if we were not to use like data source, what we could have is, let me show you. We had this output, right? We can essentially, it is what basically being put into here. So we were to have this statement. This data source we have is equal to this. So this will be true. And if we, for example, let's comment this for a second and put subnets equal, and if we were to put it over here like that, we'll delete this. And if I run Terraform plan again, it will have no changes. Why? Because the actual value hasn't changed, right? Because it, referring back to previous, it have read the outputs of our VPC, identified what's been recorded there, what private subnets we're using, and basically uploaded everything. Let me return how it's supposed to be. It was just for the sake of demo. All right. Let's see what we have. We can go to load balancers. And here is the DNS name of our load balancer. Let's check it out. Let's copy. And something is not working. It is saying connection refused. And let's brainstorm together. What might be wrong? What do you have any ideas? Boris?
Your ingress on your security group for the load balancer.
Okay, good assumption. Anyone have something else?
It's not attached to that public IP?
To which public IP?
The one where the web server is responding.
Okay, yes, very good. And Piyush, you are very precise here. So if we were to read this configuration, which parameters we have? in which, what's the name, yeah, whether it's internal or external, what's the type of this load balancer, in which security group this load balancer should live, and which subnet it should have. But how this load balancer will guess to which instances it should forward traffic. And this means we need to create a couple more resources to explicitly associate it with our load balancer, to add our instances into load balancer. And by the way, let me real quick check whether this field by default internal or not. Okay. We can even remove this internal false. It's by default in external. So for this purpose, we need to create a thing called target group. Target group is basically an object to which load balancer can forward traffic. And into this target group, we will add our instances. We need to specify a port on which it will gonna listen and a protocol, which will be HTTP. Also, there will be VPC IT, yeah, which will continue using our VPC. And there is a thing called health check. So load balancer not only distributes your traffic, but it also makes sure it only distributes traffic to instances that are indeed working, which means load balancer will never forward requests to failed instance if at least one continues to serve. That's why we need a health check. We need to explain to it which request to which port on which path it should send before trying to send actual traffic. And let me run Terraform FMT, and I will explain what all these things mean. So enable, disable, that's a switch to just to have or not have this health check. Path means connect to the root of the folder of the server. Basically, where is our page? Basically to this path like this, it will instantly redirect us to here. Traffic port means whatever port is serving. In our case, it's port 80. Same should be used to do a health check. Healthy threshold, unhealthy threshold is how many consecutive health checks should be successful in order for instance to work. Timeout and interval means if it will wait 5 minutes trying to 5 seconds trying to connect, and if not, it will consider as unhealthy. Otherwise, it will like repeat again and again within 30 seconds these health checks. So basically, to consider the instance healthy, it should be like 5 per 30 seconds. which is 2 minutes and a half. And the response code it should expect is 200, which means connection successful. And we will add our instances into this target group. We have 2 instances, which means we need to repeat target group attachment 2 times. And use count indexing over here. What it means, yeah, we have this target group that we defined previously. It's IRN, extracted as a property. We have target IDs, which are IDs of our instances, and serve it on port 80. And there is one more resource which explains to the load balancer that under certain conditions, but in our case, like always, it should forward the traffic to our target group. And this resource is called listener. That's format. And again, I'll go through it to make sure we're on board with what it means. This listener will be configured in our load balancer, which we'll create over here. Whenever connection to port 80 happens on this load balancer over port HTTP or protocol HTTP, it will perform this only one default action, which will forward the request into the target group, and which in turn make these health checks and forward the request to one of our instances, which are added into this target group. Sorry, and I confused. Of course, we should have public instance, at least for now. And there is one more thing that we need to change. In our security group, we need to add one more rule that will say, that will allow HTTP from load balancer. Otherwise, load balancer will not allow to talk with it. And we can put something like that. Instead of CIDR blocks, we can cross-reference security groups, which means everything that runs in security group 1 will be allowed to talk with security group 2 and vice versa. And we can do this by specifying it like that. Security groups equal security group load balancer and so on. Let's run Terraform apply 1 again. Very cool. Now, when we go to our load balancer, we can go to listeners. Here we are. It is forwarding it to our target group called Orlando. And in this target group, we have 2 instances, and they are already in a status of healthy. Let's get back to our load balancer, refresh, and there we have it. Hello from instance 10.0.0.182. Let's refresh. Let's refresh again. And it redirected us to the new page. Hello from instance 10.0.1.80. And when we refresh it again and again, it will redistribute requests evenly across all instances behind the load balancer. But people are still able to connect over here to our public instance, and they might find this IP somewhere, and even when we destroy the instance, they will not go to our load balancer, go to here and continue to complain, right? And by the way, let's do this. Let me demonstrate you what will happen when we destroy the instance now. I'll terminate one of them. It's 146.254. Okay, it says site can't be reached. This one's still working. It says 1-80. And when we refresh, it now always redirects us to 1.80. No? Yes. Okay. Now, how can we fix these, I would say, security vulnerability with people being able to bypass the load balancer? Easy. We can redeploy our web application and host it from our private subnets. And load balancer will work as a kind of like reverse proxy thing. It will itself sit in our public subnets and redirect the traffic to our private instances, which have the web server running. So what we need to do? Let's add one second. I thought I added. Okay. Now it makes sense. It could have worked anyway because it already has zeros, 0/0s, and these should have changed like this. Okay. Anyways, let's leave it as it is. We'll anyway delete public instances right now. So I will edit my private security group, so it can also talk with our load balancer. I will edit my private instance and install our web application using user data. We'll make this instance count equals toosh, so it will be in a highly available manner as well, and in different subnets using count index. And also, let's rename it. It should be private. We no longer need our public instances at all. And also, I will repoint my target group, this time to the private instance. And let's run Terraform apply. And as usual, while it is applying, perfect time to ask your questions. Yes, Piyush.
So can we create like one security group and refer to everywhere?
Theoretically, yes, but it won't be like secure enough. Because, for example, one server will require port, I don't know, Postgres 5432. Another instance will require SSH, like port 22. Web servers will require web ports like 80 or 443, and so on and so forth. And this means we'll have this supermassive single security group that will be like a Swiss cheese with a lot of holes.
Mm-hmm. Okay. Thanks.
Let's check this out. So let's go to our instances first. We'll have two instances called Orlando private. They don't have public IP address. Our load balancer still has the target group. It hasn't changed. And yeah, for some reason, one of our instances are in unhealthy stage and another one is healthy. This is very interesting. Let's find out why. And will load balancer work? Yes. Interesting. Let's do this. I will deregister this instance. And basically just terminate it manually and run Terraform apply once again. But that's, I would say, the beauty of this solution. even though one of our servers failed, we are still able to serve our web page properly without any problems, without any issues. Let's check this out again. Let's target registration. Hopefully it will work out. Yeah, and this time it's healthy. For some reason, probably, I don't know, maybe a package failed to install for some reason, or maybe Yama install failed. Let's check one more time. Yeah, very cool. And most importantly, now the IPs of our web servers not exposed themselves, and we only can talk, and end users will only can talk with the load balancer.